Hey everybody, it's Brad from RoboFlow, and today we're going to be talking about AI-generated art. If you've been around Twitter in the last couple of weeks, you might have seen this exploding. It's like a new genre that people have really started to experiment with, and it's pretty neat what you can create. The gist of it is that we're taking a generative model and we're able to steer it with language to produce art that is similar to what we want. It's still kind of an exploratory process right now where you're crafting prompts and trying to steer it into something, but you can't give it exactly what you want. For example, here this person told the model to steer towards time and space come to their ultimate end, and this is what the AI ended up coming out with. It's maybe not what I would have drawn, but it definitely has kind of the themes of those sorts of things. And there's all sorts of tricks that you can apply that people are discovering to make these sorts of models work a bit better and produce a bit more realistic or stylized art in the way that you want it to. And that's part of the art, is kind of choosing the prompts that convince the AI to do what you want it to do. So today we're going to go through how this works and how you can create your own. And I'll show you a little bit about what I've been working on and give you a hint of what's to come. So this is all inspired by a model that OpenAI came out with called DALL-E. You can go to their blog, openai.com/blog/DALL-E, to read all about how it works. But to give you an idea of it, we can kind of go in here and click on one of these interactive widgets. And you can see that they have this text prompt here, a storefront that has the word OpenAI written on it. And each of these is a drop-down list, so we can test it out and see what the model comes out with if we say something else. So instead of OpenAI, let's say that we want the sign to say PyTorch. So if you switch that out, you can see that now these storefronts say PyTorch. And let's say instead of a storefront, we want something else. Let's go Scrabble letters. And so now it says PyTorch and Scrabble letters. Let's say maybe we want to do something else. Let's do a t-shirt instead. And you can see that it generates that instead. And so how this works in the background is it's using another model called Clip, which if you've been following our YouTube channel or our blog, which if you're not, you definitely should, you've probably seen us talk a lot about this. This is the model that all the way back in January we used to create what we're calling our AI sandwich game. Essentially, it uses GPT-2 to generate a Pictionary prompt. A human will draw it, and then Clip, the same model behind DALL-E, scores it, which is really neat because it basically puts the human in the place of the GAN that we're about to try. The human is the one creating the art, and the AI is the one judging it, whereas with DALL-E, the AI is both drawing and judging its own art. And so we've written pretty extensively about Clip. We've written about how to try it for image classification. We've written about the behind the scenes of how the machine learning works. We've written about using it for content moderation, which we actually implemented inside of paint.wtf itself. We noticed that people were drawing inappropriate drawings, and we figured, hey, Clip knows the context and the semantic meaning of images. We can just tell it, hey, if this is not safe for work or matches any of our categories of different not safe for work things, we can flag those out and not show those in the UI. And we've also talked about some of those magic words that you can use to get Clip to perform better. And so we're going to use some of these strategies to get our GAN to steer in the right direction as well. So I'll link to all these resources below if you want to check out all of our other Clip content. But for today, what we're going to do is we're going to use a Colab notebook that essentially puts this all together and lets you steer a GAN to create images that you want. And this is what most of the people that you're going to see on that Twitter account that retweets people is going to use. It's called VQGAN, and it's being steered by Clip. So the easiest way to get started with this is a Colab notebook, which I will also link below. If you're not familiar with Google Colab, it's a hosted Jupyter notebook that connects to some free GPU resources on Google's cloud. So when you click the notebook below, you're going to want to go to File and then save a copy in your own drive so that when you make changes, those will be reflected. And then the way that the notebook works is on the right here you have some cells which represent code that you can run. And then on the left, you have a file system of files that you can access. And so you'll see mine won't look exactly like what you're going to see when you open up yours, because I've already come through and run this a couple times. And I'll show you a little bit about how that works and what I've been working on, and a hint of the post that I'm working on of pro tips around this and how to create cool things. And then also maybe making that AI sandwich a bit more into a Dagwood sandwich with multiple layers, which I'm going to create a follow-up video and post about later. So be sure to like and subscribe below if you're interested in seeing that follow-up. This Colab notebook is a little bit weird because it's in Spanish, but that's all right. You really don't need to know anything about what this says. If you want, you can paste this into Google Translate and it'll give you the English version. But the gist of it is that you need to go into each of these cells and hit the run button or shift enter to run them the first time you open it up, and I guess every time you reconnect to a new Colab instance. So this one's installing the libraries, which is going to install all your dependencies. And then down here, you can select a whole bunch of different machine learning models that'll download the weights for you to try. These are some different models trained on different public data sets. So ImageNet is generalized images. WikiArt is art photos from the public domain that are on Wikipedia. SFlickr is from the Flickr photo sharing service. And these will produce different kinds of results. So for instance, if you want to create something that looks like a photograph, probably Flickr or ImageNet is going to look good. If you want something that's a painting, maybe WikiArt. Or if you want to produce images of people, Celeb.A HQ is trained on celebrity faces. And so you can use that to steer your GAN. And so this is kind of the prior knowledge that it has of what an image should look like. And what we're going to try and do is steer our way through its knowledge to have its output match the text that we're gonna type. And so basically, the weights that you pick are all of the knowledge that your model has, and we're trying to just unlock that knowledge. And so if your model doesn't have information about the thing that you want, it's going to be tough to find it, because we're not inventing this information. We're navigating towards information that's already there inside of this GAN. And so I'll show you a little bit about how that works. I've only tried the ImageNet and WikiArt ones because I'm going to try and reproduce some of the prompts that we have on paint.wtf and see what a generative adversarial network would have drawn if it was a participant in our Pictionary game that is scored by Clip, which is really nice because since Clip is both steering this generation and also judging the game, you should expect that these models are going to be really good at playing the game, perhaps better than the humans because they're kind of on the same wavelength with the judge, if you will. So the next section is where you set up all of your different parameters here. So the text is what you're trying to generate. And if you search around Twitter, you'll find all sorts of cool tricks. One that I thought was really neat is that if you add rendered in Unreal Engine, it adds a certain level of realism to it. I've also seen people posting things like trending on r/art or a couple other ways to signify to the model what kind of output you want. I think another one I saw was amazing 4K wallpaper to kind of get the feel for it. But you can also put things in the style of the Mona Lisa, or in the style of Van Gogh, or painted with chalk or colored pencils. Basically, any words that you can come up with here, you can put different prompts separated by this pipe character, which you can type by clicking your shift key and the backslash on an English language keyboard at least. And it's going to split each of these up into a separate target. And then it's going to essentially on each step steer a little bit towards getting closer to that target. And the math behind that is pretty complicated. Fortunately, to run the notebook, you don't actually have to know anything about that. It's all kind of encoded in the background. So here, I'm trying to, on paint.wtf, we have a prompt that's a raccoon driving a tractor. Here we go. And here's the top human submissions here. of out of 3,000 people who drew a raccoon driving a tractor, what Clip thought were the closest matches to that. And you can see the humans all actually did like similar sort of drawings, which is kind of interesting because as we're going to see in a moment, the GAN goes a bit off script and creates some weirdness. But I'm interested in seeing whether what the GAN creates is scored higher or lower than what the humans created, and essentially going to compare human output to computer output. Haven't gotten quite that far yet, but I'll show you how far I have gotten so far. So on here, I created raccoon driving a tractor, and I specifically wanted to try and recreate this image that a user drew. And so while I wanted it to steer towards the result, I also wanted it to look like this picture. And so I described that picture as best as I could with a cartoon raccoon driving a red tractor with big black tires in front of a blue sky and white fluffy clouds. And then I want it to look more realistic, so I said rendered in Unreal Engine. And then you get to pick the output size, so width and height. I did 512 by 512. I've tried a few different things here, which I'll write a follow-up blog post about. I found this to be a pretty good trade-off. You can go smaller and it'll generate faster, but I found that the smaller quality ones were pretty, were not as detailed. And you can't, one thing that I tried to do was, get the basics of the outlines and have it, go through and draw a 64 by 64 image and then use that as the input to draw 128 by 128 and then grow that, which has been a strategy that people have used with GANs in the past to make them bigger. And that actually didn't work very well with this. It's got kind of stuck in a rut and it produced less good results than if I just started at the output that I wanted to. And then here is where you can select those models that you could choose from above. Right now we're on the ImageNet one. And then how often you want to print a sample image. On my Colab notebook, I have a P100 linked to this right now. Your mileage may vary. Colab kind of assigns the GPUs randomly to people. But on this, it was producing about, at 512 by 512, I think it was about 2 iterations per second. So this is printing out about 1 image every 30 seconds. So you might want it to be a little bit faster or slower. It really doesn't matter that much because it'll save them all to this file system. This is just how you get a heads up of what's going on. Just so long as you're not printing out so many images that you crash your browser, you're probably fine. Here, if you want to start from like an initial target image, you can do that. If you don't put anything here, it'll start from random, which we'll see below is what I did. I also experimented with actually starting with this output image from paint.wtf, and I can show you a bit about how that differs if you start from random weights or you start from a starting image and have it shoot towards the same thing. And I'm not sure what this one does. I haven't experimented with that. Here, if you already did something before, there's a random seed that's going to tell the random number generator what state to be in. You can take the random seed that you saved from before and put it here, and it'll rerun the exact same thing. So if you wanted to take one seed and change which direction it goes from there, this is essentially like your starting point, but in the neural networks space versus your starting point as the image space. And then max iterations, if you leave this at -1, it'll just keep running until you hit the stop button. But if you want it to only run a certain amount of time and then stop, you can put that in here. So once you're done with all those, you hit the plus button here, and then you come down to the next frame, and those are what's going to load up what's going on here. So here you see this split those up with the pipe characters. So I have 4 different targets or 3 different targets that it's going to. I didn't pick a random seed, so it gave me a random one. This is the number of pixels in the image, so the shape of the neural network that it did. And then it's using my my loss function here with the VQG model weights. And then it pre-filled it with the checkpoint that I said I wanted. And so it's going to start with the ImageNet weights on this model and this starting point and shoot towards these. And so once you hit play, then it will start making the progress bar go up. I guess this was actually down at 1 iteration per second, not 2, like I said earlier. It depends on your output size, and your GPU, how quickly it's going to go. So you can see it started out with a completely random image. This is not recognizable at all as a raccoon driving a tractor. But even after 50 iterations, you can start to see it's starting to separate the sky from the ground, and maybe has a little bit of grass here, and there's some sort of subject. And then 50 iterations later, you can start to see, I can maybe see that's a bit of a tractor. And as we start going forward, it keeps zoning in. And so you're starting to see sky here, and whatever these red things were are starting to fall away. I'm starting to see a bit of a raccoon here, and maybe a raccoon tail here. Here we're getting even better. It kind of like just is a bit abstract. It's not entirely clear why it does what it does, and every time you hit go, it'll generate a new sort of thing. But then I just let it run. And I actually let this run for a long time. This was an experiment that I did to see, what happens if you let it just keep going. Does it keep getting better, or does it stall out somewhere? And the interesting thing is that it really set this setting, the composition of this, very early, and then stuck with it. So you can see at the beginning we had those red streaks in the sky. Even here after 2,850 iterations, that the echoes of that are still here, and it had that little black thing in the middle that is now turning into a raccoon on a tractor. But it's really doing refinement even by this point, not big changes. So I let this run for 6 hours. We'll scroll all the way down to the bottom and see where we ended up at. And then the cool thing is that at the end, you can it's saving each one of these images, and you can create a time lapse. So I'll show you what the time lapse of this was over the course of those 6 hours, all condensed to just a couple seconds. So we are all the way at the end here. I let it run for over 20,000 iterations. And you can probably see as I've been scrolling that they all are kind of looking the same. But the interesting thing is that as it got better, it got more and more detail around kind of the raccoon's nose and eyes. And this tractor now has very well-defined wheels. This, for a while, was a very cool-looking raccoon tail. Looks like it made that fade away. This thing over here really changed over time. At the beginning, it kind of looked like a mahogany bookshelf. Then it looked like pipes, and then it kind of looked like a toilet. And now it's actually kind of I can maybe see how that's supposed to be a tractor with exhaust pipes or something. But maybe have to use your imagination just a little bit there. So then when you're done, you can run this script that will generate a video. And then you can visualize it. So this is a past run. You can see this has nothing to do with the one that we just did, but it's still loaded in my browser, so I can show you how it works. So this was a different prompt and a different starting point for a raccoon driving a tractor. You can see it's kind of getting the raccoon pattern at the top, kind of the tractor at the bottom, and over time it just hones in on what it's going after. And it really depends on what your prompt is, starting point, and how lucky you are, because those random weights kind of set things into motion. So basically you want to try a bunch of different things. I have some ideas for maybe how to make this process a bit more efficient that I can share later. And then down here, I linked it to my Google Drive. This isn't in the notebook, but you can Google how to link your drive, and then I copied over that video over there and then put it on YouTube. So I will now show you kind of the time lapse of that one that we just went through, the 6 hour run. I have it open over here. I actually listed it unlisted on YouTube, so I'll put this in the comments below also. But over the course of 6 hours, you can see it was just kind of playing around with what the tractor should look like, honing in on the raccoon's face and eyes, and then this thing was kind of transforming, and the red wall behind it was receding a little bit. You can see down here the raccoon tail was there at this point and eventually recedes. I'm not really sure what this white and blue thing that stayed down here the whole time was supposed to be. I think it might have been a first-person view of a raccoon driving a tractor, where we're supposed to be sitting in a cab looking at another raccoon driving a tractor. It's a little hard to like get in the mind of what the machine learning model is thinking, but you can kind of see that it steers towards the direction that you're looking to go. So yeah, that's kind of a high-level overview. Again, check out the description below for links to all these resources, and be sure to look at blog.roboflow.com in the coming days. I have a whole bunch of tests that I've run, and I'll post my results of what worked best and what strategies I used, and comparisons with human drawings on paint.wtf. So until next time, I hope that you create some really cool art. If you do, link to it in the comments below, and be sure to tag it with clip plus VQGAN. That there's a hashtag going on Twitter, and then we can all kind of see what each other make. And if you find something neat like that Unreal Engine trick or anything else, be sure to share it. We can all kind of help discover what those sorts of magical key phrases are together. So anyway, have a good one. See y'all.